Hi guys. So this video should help a little bit with the end of activity 4.4. So 4.4 is all factoring. So you have a video for that actual activity. And now I'm taking a couple examples from the exercise section just to kind of go over a little bit more with factoring if you're having a hard time. So I'm starting with one that's solving by factoring. So a couple of these exercises are just factoring, and some of them I have solving by factoring. So this one, if I'm solving by factoring, the first thing I always really want is that I have one side to be 0, which I already have here. Everything's already on one side. So my next step is I'm going to look to, if it's possible, I'm going to factor out a GCF, a greatest common factor. So when I look at 3x to the second and 12x, I see that what can divide out evenly? So I look at 3 and 12 first, and I know that I can take out a 3 from each of one of those. And then I look at how many x's they have in common. I can only pull out or factor out as many that they both have. So there's an x squared and an x, so the most they both have is x. They don't both have x squared, so I can't take out an x squared. And then I'm dividing it out and I'm seeing what's left. So if I take a 3x out of this 3x squared, all I'm left with is x. And if I take a 3x out, and I'll bring the minus down, if I take a 3x out of that 12x, all I have left is a 4. And you can always check this by redistributing. If I redistribute this, I better get that original one. And it does. When I distribute that, I get 3x squared minus 12x. So in this one, what's left in my parentheses has no more x squared, so I know that I can't factor that anymore. I would at least have to have an x squared to factor to go any further. So I'm ready to set each factor, so this is considered one factor, and this is considered another, and I'm going to set each one to 0. Remember, if I multiply two things and get a 0, one of those things has to be a 0. That's why we're able to do this. So I end up, when I solve this one, I just get 0. Whenever I pull out an x, I'm always going to get a value of 0 and 4. So this one has two solutions, which I should, for a quadratic, I should get two solutions. And you're going to see that these end up being the x-intercepts on the graph. That's how you can check your answers. So I have two answers, 0 and 4, my two x values. Okay, so let's try another one. So this one I have 2x squared plus 7x minus 15. I don't have it as solving. We're just practicing factoring, although we could easily make it into an equation and solve. But we're not going to get values out of this. We're just going to get a factored expression. So again, first thing I'm going to look for is factor out GCF. But we should say if possible. So when I look at all three terms there, 2x squared and 7x and 15, they don't have anything in common. So I can't do this. So then I start, I'm just calling it unfoiling. Okay, foiling's multiplying it out. We're going to start trying to unfoil it. Some of this takes some trial and error. In some books, they go through a couple other methods. You may have heard of the AC method. This book does not really do that, so I'm going to just stick with the method that they're doing in there, which is really just to do a little bit of trial and error. Okay, so if I'm foiling something out to get a 2x squared in the front, this is not a bad one because the only possible thing that could multiply out to 2x squared is a 2x and x. Okay, I'm taking those x squares, I'm breaking them up and putting one of them in each, and the 2 comes from the 2 and the 1. So then my next step is to come back here to the 15, and I have to figure out what things I could put in the back that could make a 15. And the sign we'll figure out later. But it could be a 15 and a 1, or it could be a 5 and a 3. Okay? And I have to find the right combination that if I put it in the back, I can make a 7x from the middle. So let me just show you what I'm doing. Like, let's say I take 15 and I take 1. And I'm checking it. So I'm doing my outer product because I'm kind of refoiling it right now. So if I take the outer product, I get 30x. If I take the inner product, I get x, 1x. So even no matter what signs I put in there, that could not make a 7. Okay, it could either make a 31 or a 29. So I know that this is a no-go. So we'll try something else. I'm going to keep the 2x and x in the front. Now I might want to try 15 and 1. Okay, if I put the 15 here, I'm not going to use this, but I just want to show you, I could try that product and do the same thing, but I think if you do that, you're going to see you still can't get a 7. So maybe I will try 5 and 3. So let's see. Out here I can get some kind of 10x, depending on what signs I put in, and some kind of 3x. That could get me a 7, and I need it to be a positive 7, which means I need this to be plus and that to be minus. So if I put a minus here and I put a plus here, now let's kind of FOIL this out. 2x times x gives me my 2x squared. When I do my outer, I get my 10x. My inner, I get a minus 3x. Those do combine to 7x. And when I do the back, I get minus 3 times positive 5. So I do get my negative 15 in the back. So I do know that this is the right product, that this is the right factoring. So nothing else has x squareds left, so I know that that's as far as I can go. But it does take some trial and error. It's again coming back to solve. So let's bring everything to one side. Okay, let's factor out. I do see a common 2 that I can factor out. And let's see what's left. Okay, so that's what's left when I take out a 2. So now I'm going to try to unfoil this quadratic that's left here. All I'm trying to do now is just this part. You can ignore the 2. I left it there, but you'll see what happens to that in a second. So this is a nice, easy one to factor when you have a 1x squared, because I know it has to be x and x. And I can do those combinations in my head. The one before that had a 2 in front, that makes it a little bit harder to find the right combination in your head. So for 14, I know it could be a 14 and a 1 or 7 and 2 in back to multiply to 14. But the only one that could possibly come out to be a 5 would be the 7 and 2. I know I need different signs because I need them to multiply to a negative 14. And I need to make the bigger of these negative to make that middle term a negative 5x. So if you FOIL this out, keep in mind you can always check by FOILing that out, and you will get what's above. So now I'm going to go one further step because this is an equation I'm trying to solve. So I'm going to set each factor. I have 3 factors here. But notice when I do this, when I do this, 2 equals 0 makes no sense. So I disregard. If I've only factored out a number, it doesn't generate an answer. But when I set these to 0, I do get 2 answers. I get a 7, and I get a negative 2. So my solution set is a set containing negative 2 and 7. So if I were to graph this, that would be where the parabola crosses the x-axis. These are my 2 x-intercepts. Because I set y to 0, really, and got those x values. So hopefully that helps a little bit with factoring. There's a ton more examples in your book you can try, and let me know if you need any more practice.